Hello, everyone, and welcome to the second half of our unit on psychology and the science of psychology. So what we'll be talking about in this lecture is we'll be picking up where we left off last time with methods for data analysis and interpretation. And so the idea is what we do as psychologists after an experiment or a set of observations is done. So it's about interpreting data. As I mentioned last time, many psychology experiments and studies will generate enormous amounts of data. And so it's not enough to simply look at the numbers. You have to analyze them, you have to interpret them. And we have to make sure that we do that carefully and responsibly. And of course, part of that is making sure that the experiment is sound in the first place. So we adhere to practices that eliminate or at least minimize demand characteristics, that we practice random assignment, we avoid self-selection, all things that we talked about last time. And then also that we're doing things ethically. So we may have a really great research question, something that we're really interested in, and we may have a great experiment in mind, but we have to be careful to make sure that experiment is ethical, that what we do with the data are ethical. So what we're going to do in this session is talk about how we evaluate data. How do we know whether a data set is going to lead to a conclusion? What conclusion can we make? How confident can we be about that conclusion? Are there alternatives? And so we'll understand how an experiment is evaluated, not just the data, but also to make sure the experiment itself is sound, that there aren't possible alternative hypotheses, that there aren't alternative interpretations of the data, because perhaps the experiment was poorly designed. We want to avoid that. It's a lot easier to design a good experiment than to go and do a lot of analyses or secondary experiments just to make up for the mistakes of the first one. It's always best to do a really good experiment up front. And of course, speaking about ethics, we have to balance the acquisition of knowledge with reasonable protections from harm, both physical and psychological, for people, and as we'll discuss, animals as well. Okay, so last time we were talking about how to design an experiment, and in particular, an experiment that used both experimental and control groups. So we talked about manipulation. That is, if we want to look at cause and effect, if we have two groups that are totally equal in terms of because of random assignment, and all we do is change one thing, and that one thing is the manipulation, how we treat one group as opposed to the other. The control group we generally leave alone, and the experimental group experiences the manipulation. So last time we talked about exposure to violent movies and TV and whether that increases aggression in children. And so the manipulation there was exposure to violent media. And of course, random assignment is really critical. If you let people self-select, that is, decide which group they're going to be in, experimental or control, well, whatever drove them to make that choice could be introducing those third variables. So if people that are predisposed to watch violent media for genetic reasons, for example, if you let them self-select, now you've got a group of people that are in the experimental group because they've chosen to be there because of those third variables, in this case, genetics. Conversely, you could pick to be in the control group because perhaps you have a non-violent nature, and you could have a bias in the control group as well. And so it's important to randomly assign who's in what group. Otherwise, whatever is driving those choices may be some of those third variables. The problem, even with that, even if you've randomly assigned your groups, is that random assignment is, as the name suggests, random. So there's always a chance that the groups you end up with aren't even. And I've modified the image from your textbook here to show you that there's an imbalance. So if you have 8 participants and you pick 2 groups of 4, just randomly you could end up with an imbalance with more people that are perhaps aggressive in the experimental group and fewer people that are aggressive in the control group. And there you've got a problem. You've reintroduced some of those third variables. because your assumption with random assignment is that all the groups will end up being even on those third variables, will end up being averaged out uh, because you've randomly assigned them. And then the only difference between the two groups is your manipulation, is your exposure to violent media. And this can happen from time to time uh, just due to random chance. But the thing is, in general, the more people you have in your groups, the less the chance of having this sort of bad imbalance. So here we've got a mismatch. We've only got 8 people. So we've got 2 groups of 4. Now imagine flipping a coin 4 times. Uh, the odds of not getting 50-50 or even close to it are pretty good because you could end up with all heads, 3 heads and 1 tail, or 3 tails and 1 head. I mean, it's actually pretty likely you'll end up with an uneven grouping with that small number. However, if you have 100 people in each group, now, well, you're asking the equivalent of, what are the odds that I flipped that coin and got heads 100 times in a row, or even 90 times in a row? And there the odds are vanishingly small. And in fact, we can calculate the odds that the groups are even as a function of the group size. And so if we get some result, some difference between the groups, we can calculate what is known as a p-value. And the p-value is the chance that a result that size is due to this uneven group phenomenon. And the odds shrink as the group size increases. So it's less likely to get really uneven groups if you have really big groups because you're flipping that coin that many more times. It also lessens the chance that you're getting a result due to random assignment, the bigger the result is. And that p-value is a probability. It's a chance. It's the odds. And it's the probability that you're mistaking uneven groups for a legitimate result from your manipulation. And so if that p-value is less than 0.05, the result is what we call statistically significant. And 0.05 is sort of random. It's a little bit arbitrary. But what it means is if you get a result that with this threshold, with this criterion, that if you go ahead and say, hey, this is a real phenomenon, the odds of it not being a real phenomenon, that is just because you mix the groups badly, they're less than 1 in 20, which is relatively slim. And of course, you can get even more significant results. You can have p less than 0.01, p less than 0.001, which means that the odds of uneven mixing in the groups and getting a result that size are less than 1 in 1,000. And now you're talking about a pretty low order probability. But 0.05 is the bare minimum. So that's a statistical estimation of how significant this result is, how likely is it that it's a legitimate observation. There are other ways of assessing how good an experiment was. So you might get a significant result from a poorly designed experiment. And so one thing is that experiments should be what we call internally valid. And what that means is that you've built the experiment correctly, that you've employed your manipulation right, that you've used random assignment, that you've avoided demand characteristics. So that means that the experiment itself works, that you're not going to misrepresent what the data say, that your data can be interpreted fairly, that you won't say one thing and it turns out the experimental result was due to demand characteristics, or that the groups weren't assigned right. So that's what internally valid means. It means the experiment works the way it's supposed to. There's also external validity. So a really good experiment is externally valid, but experiments don't have to be. And what externally valid means is the relationship between the experiment and the outside world is a valid one. So that is that the variables you define have been well defined and measured realistically. So for example, you might have an experiment that's really well designed, you get a significant result, and you've employed all the right techniques, but part of the experiment was that you assessed how happy people were based on how often they cried, for example, or that you uh, assessed people's mathematical ability based on how accurate their guesses were. So you might get a good design and a good and significant result there, but those might not be good ways of assessing the phenomenon of interest. So you haven't measured mathematical ability or happiness realistically because how you've done it in the experiment doesn't really match how it works in the outside world. That being said, a lot of psychology experiments aren't externally valid, and you don't necessarily want them to be, because you try to be as simple as possible with your experiment. So if you try to recreate the outside world, the real world, there's all sorts of phenomena going on. The world is really complex. And so if you build this really complex experiment, there's all these different sources of influence. It's hard to get a really clean manipulation while you're recreating the outside world because there's so many different influences in the outside world. And so the point of many experiments is not to recreate the outside world, it's to grab the essential properties of the phenomenon of interest. And so if you want to study happiness, then you need stimuli that make people happy, or you need a way of measuring happiness. You don't have to recreate someone's life and wait for happiness-inducing events to occur because A, you could wait a long time, and B, there'd be so much going on, who knows what conclusions you could reasonably draw from that. So external validity is nice, but it is not absolutely critical. Another question is, how can we generalize our results? So let's say we have a group of people and we found out something about mathematical ability. What can we say about the world in general? Well, one of the issues here is if we've picked a very particular population, demographically, for example, then how well does that generalize to the population of the world? And this can be translated into the question of, is our sample representative of the population? And a sample is the group of people that have participated in your experiment. The population is everybody. And this is an issue in psychology a lot because a lot of our participants are college students. And of course, college students tend to occupy a certain age range, a certain range of education, just by virtue of being college students, a range of socioeconomic status. There can be ethnic differences or sex or gender differences in select populations like that. And so that's one of the questions you have to ask yourself with the psychology experiment. Is that sample you've collected representative? So if you don't want to extrapolate a finding to the whole world, if only your particular population acts that way, if the behavior only represents a very small segment of the population. And this introduces the idea of random sampling, where you try to pull as many people of as many different groups as you can, whether the groups are sex, ethnicity, age, education. You do that to the extent that you can. It's not always possible. It's certainly not always possible for looking at things like diseases. By definition, if you're looking at a population with a particular disease, they have that disease. So that sample represents the population of people with that disease, but it doesn't represent everyone. And we have to weigh this concern against reality to a certain extent because it's not always possible to get a completely representative sample. Here in the U.S., we have a fairly diverse population. We can try to recruit that population for experiments, but we're not going to get a lot of people from sub-Saharan Africa, for example, or people from Central Asia. And certainly have people that are deeply embedded in that culture, unless we travel to those places. And so, for the most part, experiments conducted in the U.S. are going to be conducted on American citizens or people visiting. So this can be an issue. To a certain extent, we can't avoid it. And it depends on the phenomenon you're studying. So if you're looking at how people's visual systems work, it's a more reasonable assumption that everyone across the world works pretty much the same way with their visual system than if you're studying attitudes about uh, gender roles as a function of culture, because we have a particular culture here, so that's not going to be a very representative sample of the world. Whereas people's visual systems aren't affected as much by culture, and so it's less of a concern there. So we try to sample as randomly as we can. It's not always possible, and it's not always as big an issue as it is for cultural or social studies. So the question is, once we've conducted our experiment and analyzed our data, how do we interpret that experiment? Uh, and we have to be careful because our interpretations can often be biased, and biased in a number of ways. So there are the effects of expectation. Your book talks about an experiment in which participants were asked to judge the performance of a person, but were told beforehand what that person's socioeconomic status was. And not surprisingly, it affected their assessment of the person's performance. Because as soon as we're told about socioeconomic status, we bring in a bunch of predictions, a bunch of stereotypes, a bunch of expectations about how a given person is going to behave. Uh, and those are all ways in which we don't pay attention to the evidence in front of us. And again, we're trying to do this empirically. We're trying to make judgments and conclusions based on evidence, not based on preconceived notions. We can also be affected by what outcome we want to happen. So as the participant, we have demand characteristics. Uh, Participants want to please the experimenter, want the experiment to turn out well. They also want to seem like a nice person. So in social experiments, if they know they're being observed, and especially if they know the experiment is about social norms, they will act according to social norms. Whereas if they're not being observed, that's not the case necessarily. And this happens to experimenters also. Experimenters may want their hypothesis to be confirmed, and so that can bias how they interpret the data. And this feeds into something called confirmation bias. And confirmation bias is the idea that even when we're presented with a mixed bag of evidence, that we selectively pay attention to only those pieces of evidence that confirm what we already think or confirm what we want to happen. And so there have been studies where people were presented with an essay or an article on a controversial issue, like the death penalty. And half the participants already supported the death penalty, and half the participants were already against it coming into the experiment. And they were both given the same article, and both groups walked away more confident in their previous position, which doesn't make any sense because if the article supported one position, you would expect bias to shift in that direction. If it supported the other one, it should shift the other way. And if it was inconclusive, it should do nothing at all or make people more moderate in their opinion. That's not what happens. People become more extreme in their position when confronted with this mixed bag of evidence because they select only those pieces of evidence that support their position. We also tend to pay more attention to what's there in terms of evidence and ignore or not even think about what's missing. And so your book gives an example of pictures of pious or praying individuals that were saved from, I believe, a shipwreck, and saying how, oh, this practice must work, piety must pay off, because look at all these people that were saved. But no one asked where the pictures were of all the people that were pious and died, or what about the people that weren't pious and still survived, nevertheless. So we have to consider what's not in front of us. We have to think about what evidence is missing or isn't being given to us. A more modern example is insurance ads. You'll hear an ad say, drivers that switched saved $500. But you're only being told about the people that switched to the insurance company. You're not being told how much people who switched away from the insurance company saved. And you're not being told about all the people that didn't switch because they wouldn't save money. So the ad is only picking out the people that switched. And of course they saved money. They wouldn't have switched if they hadn't. So they self-selected into this population because they would have saved money. So lots of insurance companies can probably make that claim that people save money by switching to them, because no one would switch to them if they weren't going to save money. So think about the evidence that you're not seeing, that's not being presented to you. So a quick brain teaser to illustrate this point. Suppose you're in charge of quality control for a playing card company, and these particular playing cards, the odd numbered cards, should have yellow backs. And so as cards come down the assembly line, it's your job to pick out cards where you could notice errors. So if you're given these cards here, a 3, an 8, a card with a yellow back, and a card with a brown back, which cards would you select to make sure the rule is still being followed? I'll give you a second to think about it. Okay, so if you want to make sure that the odd numbered cards have yellow backs, well, you want to pick the 3. It's odd numbered. It should have a yellow back. If it doesn't have a yellow back, that rule's been violated. That's a quality control issue. And a lot of people say they'll pick the card with the yellow back to make sure it has an odd number on it. But that's not the rule. Odd numbered cards should have yellow backs, but it doesn't say that only odd numbered cards can have yellow backs. What you should actually do is pick the brown card and make sure it doesn't have an odd number on the other side. Because if it does, the rule's been violated. So people often pick the odd numbered card and the yellow back to confirm the rule, when actually it's the brown card you need to pick to disprove the rule if it's been violated. So it's a little more evidence that we often pay more attention to confirming a hypothesis than looking at what would disprove it. Now I'm going to take a second to talk about ethics. And ethics are guidelines or rules for behavior, in this context, when conducting scientific experiments. And there really weren't rules like that until the later 20th century, mainly as a result of really unethical experiments that had been done. For example, the Nazis performed a lot of unethical, harmful, even lethal experiments on people. And it's not exclusive to the Nazis. Even here in the U.S., there was the Tuskegee syphilis experiment, in which people with syphilis were observed and not helped, even though the experimenters had the ability to help them and alleviate their symptoms. But they weren't, because the experimenters wanted to see how the disease progressed. Of course, that's not ethical. You're allowing people to come to harm when they don't have to. So one of the ideas that came out of this was respect for persons, and in particular, respecting their choices, their free will, their ability to opt in or opt out of an experiment. Experiments have to be beneficent. They have to do some good. They have to provide a benefit to someone. And they have to be just. So if an experiment benefits the entire population should bear the risk of the experiment. It's not fair to select a particular population, run an experiment on them, and then provide the benefits that follow to everyone. If you can benefit, you should absorb some of that risk. So how this translated into psychology and how we do experiments for psychology is first informed consent. That is the ability of the person to know what they're about to participate in. They have to agree to it. They have the right not to agree to it. They have the right not to participate in the experiment, even if the experiment's begun. If someone wants to not participate anymore, even though they're halfway through, they have the freedom to go. Freedom from coercion. You can't force someone to participate in an experiment. You also can't coerce them physically, but also with money. So particularly people that don't make a lot of money, if you offer a large payment for an experiment, that is considered coercive, because the person can't resist the appeal of that big payment, and they may do things and participate in an experiment they wouldn't otherwise do. So you have to be careful about that. Protection from harm is a big one. You can't harm people. You can't cause them unnecessary pain. Now, a lot of the times, pain and harm are avoidable. Sometimes they're not. If the experiment is about pain, you'll probably have to induce pain somehow. But you should induce the least amount of pain that you can. And if there's a safer means of conducting the experiment, you have to do that. You have to protect people from harm to the extent that you can, no matter how inconvenient it might be for you as an experimenter. And there are committees that decide which experiments are allowed and which ones aren't. And so they perform a risk-benefit analysis. How helpful will this experiment be? What will the data provide us with in terms of knowledge or in terms of application that can help people? What are the risks involved? Do the benefits and the risks match? The benefits have to outweigh the risks. You can't risk harm to a lot of people just for some minor benefit. And then finally, some experiments, especially social psychology experiments, require deception. So because of demand characteristics, you can't always tell people what the experiment's about. If you did, they would behave in a certain way and not behave naturally. We've already talked about that in demand characteristics. So it can be necessary to withhold the purpose of the experiment or even to deceive people, to give them a cover story as to what the experiment's about. But again, you have to tell them enough that informed consent is valid. And you also have to debrief them at the end. You have to tell them what the experiment was about. You have to tell them why the experiment was performed the way it was and what the results will provide. So in certain cases, it's okay to deceive subjects. It's not preferable. If it can be avoided, you have to. But you certainly have to tell people afterwards what they were just doing. And then finally, these things are confidential, especially medical data. If you're collecting data about physiology, it has to be confidential. You can't reveal people's identity, and you can't reveal what their behavior was to the public. It is your job as an experimenter to keep that secret, to keep it confidential, and only the experimenter gets to analyze the data and gets access to the identity of the person. But of course, there are other ethical issues as well in psychology. And one of them is not about how you treat people, but about how you treat animals. And there are a wide array of opinions on animal research. But of course, anyone that does animal research has to have training. Training in the care of the animals, but also training in the ethics of animal research, so that they aren't doing some of the same things to animals that people in earlier decades were doing to people. So for example, there are ethics boards that cover animal research and make sure that experiments minimize the amount of pain and distress the animals experience. And the question, of course, is what organisms is this okay for? So people tend to get more upset about animal research that's conducted on certainly primates, monkeys, apes, but most mammals. People worry less about mammals that are less genetically related to us, so they don't worry as much about mice, although there are certainly people that do. They worry a little less about birds. And so the question is, what are the appropriate guidelines for animal research? Because again, we have a risk-benefit analysis. If it can help a lot of people, what does that mean for the animals involved in the research? How do we weigh the lives of people against the lives of animals? Most people think the lives of people are more important. Not everyone thinks that. But the question is, where do we draw that line? And also, are there organisms that it's okay to do experiments on? Is it okay to do experiments on small organisms like bacteria, plants? Do these organisms have rights as well? People tend to focus on animals, and especially mammals, because they're more similar to us. They think about things like feeling pain. But what sort of criterion is that, is the question. Is feeling pain really the appropriate criterion? And if it is, are we really just basing the ethicality of animal research on the particular animal's similarity to ourselves? And what does that mean for us? There's also a responsibility to the truth. So for example, falsifying data is unethical. So you need to accurately report what you did in your experiment and what the results were. And a lot of this gets revealed with replicability, and that is the ability of another researcher to do the same experiment that you did and get the same result. So just like instruments have to be reliable, so do experiments and experimenters. And so if someone conducts the same experiment and gets a different result, it calls into question what's different about the two experiments. And it could be innocuous. It could be differences in population because of what was available. It could be small differences in how the experiment was run. But it could also be more nefarious. Maybe one of the experimenters falsified research, or maybe they just unconsciously screened out subjects they didn't think conformed to their hypothesis. And the whole range of ethical issues happens here in terms of reliably reporting science. So you have to be honest when publishing. Again, you have to accurately report what you did in terms of your experiment and what the results were, how you analyzed the data. Were there analyses that didn't support your conclusion? And so it's important not to leave anything out, as well as to report things clearly. Also, of course, science is a collaborative enterprise. So it's important to share credit with co-authors. If someone worked on the experiment, or worked on the paper, or worked on the analysis, or thought of the experiment in the first place, you have to give that person credit. You cannot take all the credit for yourself. And more recently, with the advent of the internet, there's the idea of data sharing. The idea that if you publish an experiment and publish a result, you also need to make the data themselves available. And this helps mitigate the risk of falsifying data, or at least the risk of misreporting it. If you publish your data as well as your results, that means someone can go and check it. And so your results better match your data. And so this is another safeguard against unethical practices. Okay, that will do it for this time. Next lecture will be actually the next unit. We'll start talking about the brain. And in particular, we're going to start with neurons, the building blocks of the brain, the basic information processing unit. So we'll talk about how a neuron is built, its structure, as well as how neurons communicate, how they signal within cells. So neurons can send signals within themselves from one end to the other. But they also need to communicate between neurons. So different brain cells need to send signals and information to one another. So we'll talk about that, how that happens as well. And I will see you then.